So so something interesting happened. Actually, this happened at Cisco Live, or maybe slightly before that. But we've kind of had conversations on and off about this. It's a notion of, so I talked about cloud sourcing earlier and cloud sourced data, right? So we're in a whole bunch of customer environments, looking at their environment and collecting all of this data about what's happening there. And that data, we've used it to some degree. You saw the benchmarks and sort of industry comparisons and things like that. But there are some other very interesting use cases. So recently, we got into sort of a conversation with Apple about this. So Apple came to us, and we started talking to them, and they're like, we have this partnership with Cisco, where in Cisco wireless controller version 8.3 and 8.5, they have special code in there that helps optimize Apple device performance, right? iOS performance in particular. And Apple comes to us and they're like, did it, you guys see real environments, did it work? Like, don't you have data for this? And they're like, no, right? Because they don't see it in the wild, right? They're completely, sort of abstracted out of the picture, right? And, Cisco doesn't have the data, right? And even if they did, it wouldn't really be an independent perspective of them saying the answer would definitely be yes, right? As to did it work? And so the question was, okay, did this actually improve iOS roaming performance? And we had kind of thought about these questions, but never at a very broad level. And so we said, okay, let's look at some of the data that we have. Under monitoring right now, we see 10 million client devices across all our customer base, and around 26% of them are iOS. So it's a big pool of iOS clients. Now, as I'll talk about in a sec, it's not enough just to look at the iOS clients. You need to look at the Android, the Windows, the other clients, and see what happened to them post these changes. But basically, it turns out that we're the only ones that have this data right now. And so, we decided, okay, fine, let's look at this. And so the methodology we decided to use is we said, okay, there are a lot of things that go into roaming performance, right? Coverage, the speed of your radius server, a lot of other things. And we said, okay, that analysis will take a long time. Let's just do something very, very simple. Let's just look for customers that upgraded their code. And so we automatically track code upgrades because we look at configs and we do diffs on config. So in that network history page that I showed you, that baseline, you may have noticed some annotations. Those annotations show up automatically if there's a configuration change, or you can manually annotate it as well. You can say, oh, I did this or whatever it is, and that'll show up, right? But the code configurations that falls in the automatic bucket. So we know when a customer upgrades from 8.2 to 8.5, or typically they won't do that. It's like 8.2 to 8.3, 8.3 to 8.5, that kind of thing. So we said, okay, let's take a long enough time period, like a year, right? And let's look for customers that within that year upgraded from a code version of Cisco's previous to 8.3 to something greater than 8.3, whether it's 8.3, 8.5, whatever it is. And let's just analyze what happens, right? Across a single customer that has enough clients, across many customers simultaneously, right? So that was kind of our initial take on it, right? And so this is what we found at a single customer. So actually, let's see. All right. So this is a single customer, but a gigantic customer. So this customer has 20,000 simultaneous iOS devices, and probably from an aggregate perspective, hundreds of thousands of them, right? They have around 5,000 Android devices, 6,000 Mac OS X, and whatever else, right? So it's a pretty good controlled experiment, if you will, because one of the other problems when you try to aggregate the data is that different people have different coverage or different models. All the different factors come into play. When you look at a single customer, at least you know that all those are corrected for, right? And so we looked at it and we saw, this is really hard to read, but basically the starting point over here, the y-axis on our baselines is percentage. So we look at all the clients that roamed at the same time and what percentage of them had bad roaming. And we have our metric sort of defined as, a bad roam is when we see sessions drop, right? So we see a whole bunch of TCP fin and reset packets right after the roam. Or we see that the time it took to roam was really long. Or we see that the retransmit percentage on TCP went up. We classify that as a bad roam. And we do that at all times, the same measurement, same thresholds, same thing everywhere. So we actually did see a huge drop in iOS. So iOS went from around 8, at this particular customer, it was around 8% to 5% or 4 point something percent. So like a 40% increase for iOS. And the other operating systems, interestingly enough, Android, Windows, or Android, Chrome OS, Windows, barely budged, right? So they didn't change at all. So we're like, okay, this actually did work. The caveat to this is iOS started out really bad. That's the part Apple doesn't like to hear. Apple started out at 8%, Android started out at like 3% or 2.9 or something like that, right? So there was a lot more room to grow for iOS than the other ones. Nonetheless, the fact that we saw the other ones barely budge was an interesting sign to us. And so then we sort of went one step further, and we aggregated across many customers that sort of had this feature of 8.3, 8.5, that kind of thing. And overall, I mean, we kind of found very similar results. 25% increase in iOS. The other operating systems, OS X, and it's supposed to help OS X too, but I just didn't see that necessarily. And Android, Chrome, Windows, not very much change at all, right? And so we said, oh, let's write up something about this or whatever. So we're going to talk about it publicly probably next week, but this is just a side project that we did, and it's interesting. I mean, it has a lot of scope. Yeah, that was the conclusion we kind of came through. Although that bracket, as I said, is the part that they don't like. But well, hey, that's what the data says.
Made it better, but not even as good as its best competitor.
That's
now,
right.
so now you need a premium wireless solution with a premium priced handset solution to get. Yeah.
I don't know.
It'll be twice as bad as the cheap NAS.
I'm smelling a conspiracy here because the only number that was negative on performance was Android.
Yeah, that's true, actually.
Yeah.
Android got worse.
Roaming.
Android got slightly.
So Android got worse to the level of everything
Trying to level the playing field, exactly.
That could have just been an upgrade to Android, though.
Although, okay, so one thing in fair, I don't know why I'm being fair, but Android is a very broad term as opposed to iOS. iOS, it's iPads and iPhones, right? With Android, I mean, it could be on almost anything, right? And there's probably a lot of static IoT devices that are Android as well. And for this analysis anyways, we didn't try and break that out. So, maybe there's probably room to, debate and whatever else, whether a true Android handset compared to an iOS handset, what's the true difference there? But, either way, this is, but it's just something interesting that when you have a data set across real network environments with real usage patterns and actual devices versus synthetic tests or anything like that, there's just a bunch of really interesting things that you can do with that data. And this is just one example of that thought I'd share with you guys. So,
is this sort of analysis something that is built into the tool that we would be able to actually do ourselves?
So, not in terms of taking cloud source data. So the cloud, I mean, so in general, we're very protective in anonymizing, customer data.
Sure.
On that front. But what we do is, actually there's a page, if you just Google it, called Voyance Live, where we try and aggregate a bunch of data and present some kinds of analyses. This was an example where it's actually, we wrote it up as sort of a report. So this was a very custom kind of, we did the analysis. But yeah, to your point, I mean, we do want to release more and more publicly that's aggregated across the entire data set. Versus, I mean, customers use it too in terms of now they can see a perspective, but definitely, that's something we're
But the same data, not the crowdsource, but the same data for within your network is available to you to do this. If you were were that large customer with 20,000 iOS devices, you could go in and essentially do a report on your organization. You just don't have access to everybody else's
Exactly.
data.
Exactly. 100%. Yep.
Okay.
Yep.
Great.
Yeah, exactly. And in fact, you can do that via APIs. You can do that within the product. There's reporting. You can do it that way. Right? If CSV is the API that you want, either way. It works in all cases. So, but but yeah, so that's basically what I had. So
Thank you.
thoughts, questions, comments.
Can you go into any more of the metadata that is sent? I mean, can you give some examples of the fields that are included in that?
Yeah, for sure. So, the basic identifiers, MAC address, IP address, host name, all of those kind of VLAN, SSID, all of that. Then there are the applications that a client uses. For each application, a breakout of things like byte counts, TCP latency, performance. For each protocol used, sort of a measure of the protocol interaction, right? The discover got sent, did the offer come back? Well, okay, the offer came back, but did the request get sent, and so on, right? From a syslog perspective, we're collecting reason codes, right? So the metadata there is the code itself, but tied to a particular user and a timestamp, right? From NetFlow, well, NetFlow is NetFlow, right? It's whatever comes in. We try not, some customers actually have additional data in their NetFlow, like they have app ID, they have, response times and things like that. We kind of look at that as gravy. We don't expect it because across most of our customers, we haven't seen that to be the case. Just because NetFlow, when you enable all those extra things, tends to bring the performance down on the router. So we don't, sort of expect them to have it. What else? On the wireless side, signal to noise ratio, what access point it's connected to, interference levels. So those are the kinds of data that we're getting back into the back end.
Do you have any issues with time differences amongst clients and
data sources and things like that? Definitely. And so it's all about how do we align all this data? How do we make sure that the same user, as the question came earlier, how do you know that this data that came from NetFlow is the same user as this other MAC address that we saw? And we have to sort of make allowances, sort of buffer data, and figure out and make sure we match it up correctly before we go into analyzing it and stuff like that. But that's definitely a problem that we have to solve, and that we do solve sort of in the product. Yeah.
Thanks.
Yeah. No problem.